Okay, so in this question for exam 1 review in 115, looking at a energy transformation question, sort of human body question and workouts. So we've got a person who's doing a cardio session at the gym. She does a 20-minute workout on the treadmill, and we're told that the total metabolic power for this exercise is 520. So that includes the entire energy output for the person, or how many joules per second they're using of their internal energy. And then they do a rower workout where the total metabolic power is 650 watts. And if our total workout results in Danielle using 288 calories, how long was her workout on the rower? So quite a few parts of this question. So we know what the total workout calorie burn is, and we could figure out the calorie burn for the treadmill. So we would just subtract the total calorie burn, total calorie burn minus the treadmill calorie burn. We could figure out what's the calorie burn for the rower, and since we know the metabolic power for that exercise, we should be able to eventually figure out the time. So I think our first step is to figure out what's the total energy burn in units of joules, since these units of watts here represent a joule per second. So the first step is to figure out what's the total energy for the workout. So it would be 288 calories. And that's uppercase C here. So that's a food calorie. So 288 calories, and there's 4,190 joules per food calorie. And we can cancel out those calories. We should end up here with a pretty large number. 1.21 by 10 to the 6. Okay, just zoom in here. Okay, so that's the total energy burn. Now to figure out the energy for the rower, so the total energy comes from the energy used in the treadmill plus the energy used in the rower. So sort of my step 2 here, so the energy for the rower will be equal to the total minus the energy of the treadmill. The energy for the treadmill is a 20-minute workout at 520 watts. So the energy for the rower is that total 1.21 by 10 to the 6 joules minus, to get the energy of the treadmill, we've got 20 minutes and 520 watts, so that's 520 joules per second. 20 minutes times 60 seconds per minute. So those minutes will cancel with the minutes in the 20, and the seconds in the 60 will cancel with the seconds, leave us with joules. So the E of the rower is 1.21 by 10 to the 6 joules. Just for a little extra detail here, the joules for the treadmill, 6.24 by 10 to the 5. So the energy for the rower equals the subtraction of those two, so 5.83 by 10 to the 5 joules. Okay. So now we've got the total energy for the rower, and we know that the energy of the rower takes up to 650 joules per second. So our last step here, which is this. So the time for the rower will be the energy of the rower over the power for the rower. So that's 5.83 by 10 to the 5 joules, all divided by 650 joules per second, which will leave us, of course, just with seconds. So this works out to be 896 seconds. So very close to 900, of course, which is 15 times 60. So we want to get this into minutes. So the delta T of the roar in minutes will be 896 seconds divided by 60 seconds per minute. And that should give you 15. So she spends 15 minutes on the roar. And so a 20-minute workout, 20 minutes on the treadmill, 15 minutes on the roar gives a total workout of 288 with these two metabolic powers for the total metabolic power. And there's no need to worry here about the efficiency in these questions because this is given us as the total metabolic output. So that's the entire energy used for the person for the entire exercise.